Audible?
Okay, hi everybody and welcome to the Multi-tenancy Working Group meeting on October 22nd, 2019. Today we have an agenda where Sudeep Batra from AT&T will be going over his multi-tenancy building blocks document that he has been putting together and would like to discuss. And then we have a group of people who have been working on a multi-tenancy benchmarking proposal and have a document that they would like to discuss. So Sudeep, I'll hand it over to you.
Thank you, Tasha. Am I audible? Hello, am I
Yes,
audible?
you are. Go ahead, Sudeep.
Okay, yeah. I was just trying to understand that I'm audible properly, right? Okay, thank you. So let me share my screen. Hope it is visible.
Yep, I can see it.
Yep.
Okay. So yeah, so basically this there was discussion I initiated with Tasha and trying to understand, if we have like end-to-end view for this multi-tenancy and if we can put the building blocks around it. So Tasha suggested that I can start that. So, since in AT&T we are also looking for the instantiation of our tenants, and we wanted to use that knowledge to add here. Of course, here the attempt is to keep it as simple as possible, because in our organization there are a lot of specific scenarios which are not obviously not specified here. But yeah, I mean, I'm very open to the suggestion to how this can be enhanced further so that it is helpful for everyone. Okay. So with that, I will just start. So this is just work in progress document, and the idea is that it should act as a guide for any enterprise to look at the various building blocks which they need to address in order to utilize the multi-tenancy for instantiating their various tenants. Okay, so at the first stage, we figured out that it would be good to start with like these 9 building blocks. There could be more, but these are the ones which we are looking at. And starting with the first one is like the multi-tenant onboarding to the cluster. And in that, basically, we are considering the platform which is necessary for onboarding the tenant. So this comprises of the tenant operator, basically the application controller, and the CRDs which are created. So all those prerequisites which are necessary before a tenant can come and launch its resources using that tenant CRD. Then the next building block that we can see is the CNI support for multi-tenant networking. And here there are various mechanisms which would be helpful for a tenant, like specifying separate IP pool and VLANs for each tenant, and the associated routing and network policies. So all those details should be coming under this second block.
So just before you go on, can I ask you just to zoom in a little bit, maybe change your zoom level to 150 or 200, just so I can see. Yeah,
Is that
just
better?
That is better. Yeah, I'm just not on the biggest screen right now. Thanks.
Sure, Adrian, no problem. Thank you. Okay. So yeah, so the second block is that the networking CNI support for the multi-tenant, and then the third block is the tenant resource isolation. In this, we are considering the various isolation mechanisms which are used for the different multi-tenant environment. Namespace is, of course, the most important one, because that's a mechanism we are using for isolating the tenants, but also like what additional we are doing inside that namespace, like the associated resource quota per tenant namespace and things like that. Another one inside that will be like the access isolation, So, each tenant should be securely isolated to access the Kubernetes API server, and he should be limited to instantiate the resources associated with that tenant only. So we are talking about separate user permissions and the context, those kind of things as part of that access isolation. And then there are also other things like storage isolation, where we need to look into like how the backend storage pools can be, that can be separated out for each tenant using storage class or mechanisms like GID, group ID thing that we have. And then also hardware isolation, which can be like using pod node selector or node labels to specify like, specific node for a particular tenant. And then also very important in the tenant resource isolation will be the tenant container security aspects like the pod security policy, app armor, SecComp, tenant container immutability, liveness and readiness probes. So those kind of things, all these we are looking at covering under this building block for tenant resource isolation. Then the next important block that we look at is the RBAC. So in this, we are considering the different roles and the role bindings that is needed for different multi-tenant users.
Can I just ask a quick question about that? You mentioned
Yeah.
the tenant CRD before. If you're using the tenant CRD, I assume that you would be relying on that for your RBAC or most of your RBAC. Is that the idea?
Yeah. So, I mean, that is correct, Adrian. But I mean, the main idea is, that if we want to focus on any particular area, we should have like a building block where that associated criteria, the requirements are clearly outlined. So, we know like, okay, all of these together make up the multi-tenancy, so that was the idea behind it.
Yeah, so tenant CRD might bootstrap you, but you might also want to use have other policies as well.
Yes.
Okay, thanks.
Is something like the open policy agent kind of more site-specific policy kind of things kind of fit in that RBAC box as well, or is that kind of a different box?
Yeah. That's the idea. LDAP or yes, open policy agent. Those kind of things.
Yeah, maybe we can change that from RBAC to basically something like policy enforcement or something like that.
Yeah.
But we are considering only the like user roles and the privileges associated with that users roles, things like that here, right?
But there could be something like open policy rules that say if they have this particular capability in that namespace, then they're allowed to use this particular annotation on an ingress or that sort of thing, right? It's more specific policy to your cluster than just RBAC can provide all on its own.
Okay. Yeah, that sounds good. Yeah, I mean, it would be good to, add comments to my document so that, it can be enhanced further. I mean, I welcome that very much. Yeah. All right. So the next building block that we are considering is the image repository. There should be a secured image repository, which could be like Artifactory or something like that, which should support the multi-tenancy and also the associated tenant image isolation in that, right? So that's this building block for secured image repository. The next one is related to the LMA, logging, monitoring, and alerting framework, and how we can provide different view for individual tenant-specific logging, monitoring, and alerting, and associated feature for that. Okay, and the next one is the Kubernetes cluster component upgrades and impact to individual tenants. So this basically, we want to look at that when there is any Kubernetes version upgrade, then that during that version upgrade, the existing tenants traffic and orchestration, that should not be impacted. So you have to look into that aspect as part of this feature. And also another add-on feature is the multi-tenancy user experience via GUI. So a graphical user interface can be used by the tenants to create the resources in their specific namespaces, and that GUI should be integrated with RBAC. So those kind of things. And then finally, the CI/CD pipelines to allow the tenants to um, uh, automatically instantiate their resources. So this will need separate pipelines or things like that for the tenant. This could be again an add-on thing depending on the type of organization, but I mean these are of course taken from the experience how we are planning to do in AT&T, and I mean this is just the start, but we intend to add more and more details in this document as we are working on it, and we are getting the details here. So so this is like summary of the details that have been talking about. And in section 2, we have the background. I will not go through this because this is already known to us, like how we are using the tenant CRD and tenant admin namespace, and just some of the steps that I did using our multi-tenancy, documentation that was there. So I just thought of putting it as a background. And the most important section is this detailed design. Here we intend to elaborate the what, why, and how for each of the building blocks. So like the requirements explaining what we intend to do in each of these building blocks, and the associated design architecture explaining why we need it or what's the background, and then some of the code details explaining how it will be done, maybe reference to the GitHub issues associated might be helpful. And then of course the testing or the validation to ensure the fulfillment of that requirement. So I was happy to see the, yeah. Any questions?
Sudeep, so let me add one point here, which is so there's similar efforts in the area of cluster profiles definitions, as well as the validation and benchmarking work that I think is going to be talked about next.
Yeah.
So
exactly.
And what we have been thinking, I'll just mention briefly, we'll need to continue discussing this offline, but is, how much of this sort of thing needs to be in the GitHub versus reference implementation examples in Google Docs outside of GitHub. So let's have that conversation separately. And then we can sort of formalize as to how opinionated we want to be in the GitHub, as opposed to providing suggested implementation examples, which may or may not be in GitHub, which could continue to be in Google Docs.
And a further step yet would be like integrating it to the kubeadm reference implementation. I mean, it could even go so far as it's a flag when you start your kubeadm cluster to just have it.
Right. Yeah. So those are, we have to come to a bit of a consensus on how much of that we precisely specify in the GitHub and how much of that is a suggested reference example, but just one example, right? So keep going for now, but we'll have to converse offline as to what kind of, there are 2 or 3 semi-overlapping efforts. How can we sort of commonize it and take it forward? Okay.
Yes. Yeah. That makes perfect sense, Sanjeev. Yeah. I mean, the idea is like, that any organization comes, he has a single reference, and there could be further references to like kubeadm and other areas. But yeah, I think it will be acting as a single end-to-end, building blocks for the entire multi-tenancy. And hopefully it helps anyone And also with the experience that we are having in AT&T, that can also help everyone, because that's very prime objective in AT&T to, do open source and, contribute whatever we are doing to the community. So
Are you
yeah.
using the tenant operator at AT&T right now?
Not yet, but
Not
we
yet. Okay.
intend to do that. And we want to work very closely with the working group multi-tenancy. So that's the reason, I've been so active in the community and asking and, look at the various things that you did, Adrian, as well as Guo you had created. So yeah, so
Right.
we'll continue
And
to do that. Yeah.
and by the way, the agency is rapidly approaching the stage where you'll be able to actually take it and start playing with it in some kind of semi-realistic way. We're getting all
Yeah.
of the guardrails in place, and so you can start evaluating that as well.
Exactly. Yeah, I think that's the idea, right? I mean, we want to really take it and use it in the production environment and take it to the next level. So for that reason only, this question came, and I was having discussion with Tasha that if we have a building blocks which could, help
Hello?
to get an end-to-end view. And I was also happy to see this benchmark or the validation feature by Damien, right? And when I looked at that, I felt that there is a lot of synergy between the building blocks and the associated validation needed for each, and the benchmark or this the other proposal which will be in the next
Yeah,
discussion, right? Yeah.
yeah, that's why Sudeep, I said that we are consolidating efforts because there's multiple activities which are semi-overlapping. So we'll
Right.
take it offline to kind of make it most useful. But let's keep going for now so that you kind of summarize it for now, and then the details we'll be able to go over.
Yes, so Sudeep and Sanjeev,
Yeah.
this is Jim from Nirmata. So definitely this is very helpful, and I think this can align very well with the categories and things we'll cover when we go through the benchmarking proposal.
Yeah.
Because really what and we'll talk about that in more detail as we get to that, but we're not so much focused on, how exactly something is achieved, but measuring the outcomes, right? So one
Right.
question I did have on the building blocks, I wasn't it wasn't clear to me where ingress controllers are covered or if they're not, because that seems like an important piece and something that we're dealing with.
Yeah.
So
Yeah. So I think the ingress controllers, yeah, this has to be, yeah, we have to think
So,
about this.
yeah, you
Well,
talked about Kubernetes entry points, right?
Mm.
So that should be part of the building block where you discuss the tenant isolations and the access to the users to the Kubernetes API servers themselves, right? So they go in line with the ingress definitions you would do, not just for the native Kubernetes API, but also for any of the operators that you might expose as part of the tenant specific operators, not part of the whole Kubernetes, right? So,
yeah.
So
I think that's, yeah.
So
And,
these are
and
all, one point I want to kind of mention here is that um, firstly, these are all good points. Now, the key point is this, which is how opinionated do you want to be about reference implementations? Because
mhm.
some implementations would choose to have an ingress per tenant versus some
right.
implementations would choose to
Right.
have a shared ingress across tenants. And
Right.
are we in the business of specifying every combination of multi-tenancy options, or
Mhm.
just showing one reference, but having a
So I
that's
think
something we need to have.
as we kind of discussed earlier, do we want to have a implementation or lots of implementations? And maybe the answer is it depends on the feature. Maybe some things like the tenant controller, that is just a given and everybody uses that. And maybe we provide some like reference documentation if you want to do ingress this way or that way. Uh, that one's more an option.
Right. So maybe at the
Okay.
highest level, the requirement is that tenants will want to expose their services to an external network, right? Whether it's done
Mhm.
through ingress, load balancer service types, doesn't really matter. But it's, just like you would with the PaaS, really what I want to do is run a workload and get a endpoint where I can connect to that workload, right? So how do I do that in a multi-tenant configuration?
Right. I think that's a very valid point. And as Avinash was talking about, so I think that could be added as part of the access isolation,
On
or
the
it could be,
networking,
or
yeah.
on the networking side as well, because yeah, because we define the services and the ingress, whether per tenant or a common, but I think it should come in there, right? So at least we can maybe call out at least the requirements, and then it will depend on case to case basis how it will be used in different scenarios, right?
Okay.
But yeah, so basically the idea is that, that if we can call out all these in terms of like the requirements, what we intend as part of each of this building block, and then the details. So it will kind of act as a reference for, any organizations, that these are the options and this is how they can do. So that will hopefully help to, utilize it in a more wide scale manner. So that was the intention. So I already talked about it. I mean, I do not have much details rather than, that other than that, we have to add those requirements and the corresponding code references and those details yet. But I mean, the main objective for this discussion was to align and, get a feedback, early feedback that if this is going in the right direction and if this will be helpful to everyone. So that was the main purpose, Sanjeev.
Yeah, absolutely. And again, like I said, this aligns with efforts we have to
Yeah,
essentially create an end-to-end architecture that unifies all these different threads. Right? We've got a thread going on with the tenant controller. We got a thread
right.
going on with the hierarchical namespace. We
Exactly.
had
Right.
some work earlier, which we have started on cluster profiles. Now we've got the validation suite. So we are going to document a unified architecture that unifies all these threads, but we still need to figure out whether that is going to be an opinionated architecture or a reference architecture or some combination of the two. So let's continue that discussion offline.
Okay. Sure. Sounds good to me. So yeah, I think that's all I have as of now. So yeah, I mean, I really welcome everyone to take a look and give feedback so that it can be enhanced and, useful to everyone.
Thanks.
Okay,
I'll try to have
over
a
to
look at
you,
it as well.
Tasha.
Thank you,
Over to
Sudhir.
you, Tasha. Thank you.
Tasha was having some audio difficulties. Tasha, are you still okay on audio? Tasha, you're on mute. Tasha, can you hear us? You're on mute. If not, I think Jim shooting, you guys can try to take over the ball if you can.
Okay.
Yeah, I don't believe that Tasha can hear us either. I got a text message from her that she has lost her audio. So
Yeah,
she
go
may
ahead.
be on. So yeah, you can drive.
Okay. All right. So this is, hey everyone, it's Jim from Nirmata. And I think what we just, and it's a great lead in from the previous topic. What we wanted to do is talk about a proposal to create a set of benchmarks, a set of standards, and a corresponding or a validation test tool that goes along with that, to verify if a cluster is set up for multi-tenancy. Right, and really just this came out of a discussion with Sanjeev where we were talking about the different things going on in the working group and where we could potentially help and contribute. And there are, of course, are a lot of different proposals, like whether it's the tenancy RD, the HNC, policy-based ways of managing namespaces. Uh, so we really did not want to focus much on how multi-tenancy is configured or achieved, but really trying to see and figure out or validate if a cluster is correctly configured, right? So that was the high-level sort of thought process that led to this. And as we dug in a little bit deeper, it seemed like what would be of value is creating a set of standards or best practices and outlining what those are in terms of what needs to be achieved, and then creating also a test tool which could be run on a cluster given some simple configuration to validate if the cluster is set up to meet different levels of multi-tenancy. So that at the very high level is what this is about, and this is a proposal document. It's not intended to be the final result, or we have samples in here based just to clarify thinking and get feedback. And so really we didn't intend for this to be a document review. Of course, everybody's free to comment and provide feedback on the document itself. But what we wanted to do was get, mainly verify that this is a reasonably, I guess, or this is a reasonable effort, something we should pursue, something which will provide value to what everybody is trying to achieve with the working group, and fits in well with the other projects.
Yeah, James, again, so go ahead. But I just wanted to again put the context here that again, this aligns with the direction we've had, which is having an overall reference architecture, having cluster profiles, and then having, whether you can call them conformance tests or validation tests,
right,
to enforce those. So this particular document is along the lines of a framework for the validation tests. And the good thing
correct.
is that it aligned exactly with the different models of multi-tenancy, whether it is the using a self-service model, not using a self-service model, or all the way to a virtual cluster like that.
Exactly. Yeah, and it seemed like the commonality across all models was, of course, namespaces are the central point of configuration. There's a lot more that needs to be happen, and then various levels of multi-tenancy could be achieved. So yeah, so I'll just quickly go through the main intent, and then Damien's going to cover more about the type of categorization of the benchmarks that we have thought about. And then Shooting is going to show a quick demo and an example of actually a test case. So we just wanted to do just a really like an MVP to see, is this a viable thread all the way through? And that's what we want to get feedback on, and then we'll decide how we kind of, as we dive into this, how do we organize, how do we collaborate, and actually formalize the effort. Okay, so just to quickly cover the goals here and make sure that we're sort of at the right level. So what we wanted to do again was create this set of standards, so document what's required to configure a cluster, so that there's sufficient isolation, and then provide a test tool for that. And we may not initially, of course, we may not kind of go through each conformance level or each profile. And by the way, one thing, and I know there were some comments on this, so the terms we're using are heavily inspired by like the CIS benchmarks for Docker and CIS benchmarks for Linux and Kubernetes. So they have the same sort of benchmarks. There's of course tools like KubeBench out there, which are validation tools, which can guarantee or try to validate that those benchmarks are being met. And then there's the benchmark specification itself, right? So that's kind of what we're thinking. And the benchmark specification provides the different profiles or the different levels that can be achieved based on the requirements for whoever's operating the cluster.
Well, one thing that you might add to the title is just call it a security benchmark or something, and it might be a little more obvious what it is.
Okay.
Is that just a security benchmark? I thought it was like beyond that. It's covering everything, not just security, right?
So the intent was multi-tenancy, just focusing on multi-tenancy, right? So that's sort of why we went with multi-tenancy benchmarks, security-based, over, of course, a lot of other areas beyond multi-tenancy.
I think security is implied by the term multi-tenancy.
Right.
So, but if we, so I think it's fair to just keep it as multi-tenancy benchmark, because if you explicitly add the security in there, that seems to focus more on security. I mean,
outside the security space, benchmark tends to be more like performance and things. And so the initial feel of it is like, is it performing adequately? And it's really not about that, I think, right?
this is not a performance benchmark, right? And I think there's a discussion about calling it a validation suite, perhaps.
Right.
But it is a set of conformance tests, for lack of a better word, although we don't want to use the word conformance, which confirms that whether it is the secure isolation or whether it is, quota management, or whether there's some other aspect that is adequate, so that you can put a number on this cluster meets 8 out of the 10 requirements for multi-tenancy, and you can put a
Right.
quantitative feel for it. Otherwise it's all subjective hand waving, right?
Mm-hmm.
Yeah, so if benchmarks is not, is confusing or is not a good term, another potential candidate would be standards, right? And really that's like, if you look up the dictionary meaning of benchmark, standards is one of the meanings. Okay, but
reference CIS benchmark has a bunch of items which are scored and then which are mandatory and optional. So you essentially add up the score. And
yeah. But the CIS benchmarks kind of have S security in its title.
Well, the CIS is the name of the organization, but the benchmark is for Kubernetes. It's not for Kubernetes security. It is a overall benchmark for Kubernetes.
Yeah.
They happen to be a security organization. We happen to be a multi-tenancy working group. So we're building a benchmark for multi-tenancy.
And naming things is always hard.
Right. So we can, and of course, this is something we can evolve and change as needed, but yeah, let's continue sort of the discussion and getting comments and feedback on that. So things which we did not want to tackle right away is like, I think in the previous presentation, Sudeep also mentioned like cluster add-ons and services. Those are a little bit, I guess maybe a next level of multi-tenancy, if you will. And then of course, multi-tenancy across clusters, because interesting question here is how much of this should be in a single cluster versus is there something, how much of it belongs in an external management plane, right? Or like with having like a, sort of a system cluster and then tenant clusters or other models that, that are also being discussed, right? So
I think
those
you're
things.
talking about cluster API here, right?
Yes, to some degree there may be some interesting things there, but we did not. For now, we just wanted to focus on a single cluster, right? So in the future, we could expand this to multiple clusters and things to that nature. And then, of course, one of the main things here, which if we don't want to advocate any particular, at least for now the working group may, but from the benchmarks perspective, we did not want to advocate any particular mechanism or tool. We just really wanted to kind of think about, the what are we trying to achieve, and how do we measure that has been achieved for that cluster itself. Okay, so I'll skip past some of this, but please feel free to comment and add to this. I'm just going to go over some of the relevant sections and then hand off to Damien. So on the tenancy model, again, it's just a very the loose definition here is that it's a user, a group of users that have access to a set of namespaces that are isolated from other namespaces, right? And of course, there's a lot more to it. There's a lot of like the things we covered in the building blocks, but for now, this is kind of what we said is, this is what it means to be a tenant of a cluster. And the three roles that we were thinking of is there's of course the cluster admin, there's a tenant admin, which has been discussed with in various forums, and there's perhaps a tenant user, which again, we did not want to mandate necessarily, but we'll see if there's some of the validation tests require that role to be configured. So far, we haven't seen that, but this is something we could introduce as a mandatory role if it's required for a validation test. And then another interesting aspect, which I think is worthy of discussion here, is this, like you were, Sanjeev, you're mentioning the cluster profiles. We just called it multi-tenancy profiles over here, and roughly we were thinking of 3 levels. And interestingly, and maybe it's not coincidental, but it maps really well to a lot of the activities going on in the working group. So the first level doesn't really matter. Again, like for none of this, it matters how the namespaces are configured. But what we were thinking is just using standard Kubernetes. If even if the cluster admin manually configures the namespaces, that's fine, right? But we want to make sure that the Kubernetes control plane is isolated from tenants. So a tenant cannot, launch like a denial of service attack, or cannot, access things in the control plane they shouldn't be allowed to. Everything in this level uses standard Kubernetes resources. So no requirement for a CRD, a controller, or anything like that. And it's understood that some features may not be allowed, right? So it's a compromise here where at this level, some Kubernetes features like a tenant cannot install their own CRD or anything like that. The second level kind of builds on top of the first level, and it really just all it introduces is self-service for the tenant administrator, or somebody who has access to the cluster to be able to then provision their own namespaces and manage their own users. And this is really, we're thinking of like the HNC as one way of implementing this, right? So, and there might be others. There might be, we've seen like I think there were proposals, and folks in the community had shared things like Helm charts. There's other CRDs. In the last meeting, there was a discussion from somebody from Red Hat. They had a different CRD to achieve something like this. But the idea here is self-service for tenants and tenant admins. And we can decide, like, does it mean that the initial admin has to be configured by the cluster admin, or can even a tenant they have some level of access to the cluster, and they can create their own virtual cluster or namespace as needed. And level 3 builds on top of that again and says, now, this is complete isolation, where even the control plane is virtualized, and tenants should be able to install their own CRDs, and this is the virtual cluster proposal from Faye and team, where it sort of seems like perhaps one of the highest levels of of multi-tenancy that can be achieved. And of course, that requires some extensions and some changes to the control plane as well. So let me, if there's any questions, thoughts here we could discuss, or just for the sake of time, maybe, we can let Damien and Shooting complete and then pick up either in a subsequent meeting, or just we can do comments as we go through.
Thanks, Jim. Hi, this is Damien with Nirmata as well. So the next question we tried to address is really how we're going to test and what we're going to test. And at a high level, really, what we could see is that there are two different types of testing we could do to check for multi-tenancy. So the first one would be testing the configuration of the cluster, testing the configuration of the namespaces, or testing really the behavior, the outcome, just verifying that multi-tenancy has been achieved. Our proposal at this point is that probably it would be good to use a combination of both, and to decide, depending on the tests we are doing, if we should check for configuration or for behavior. One could argue that we should always check for the outcome, for the behavior. But there's also maybe a possibility of simplifying the test by, in some cases, testing just for configuration. So let me give some examples here. The rule of thumb could be the following. If there is only one way to achieve a certain multi-tenancy criteria, and it is through configuration of the cluster or of a namespace, then it would be sufficient to just test for configuration, right? We wouldn't have to test for behavior because that would be redundant. At that point, we would test Kubernetes itself, that Kubernetes is correctly implemented. So an example of that, let's say, if we agree that there's only one way to limit the amount of memory used within a namespace, and it is through resource quota, in that case, you just have to check that there's a resource quota configured for namespace for memory, for that quantity, and that would be sufficient. You don't have really to create, pods consuming memories to verify that at some point they would be rejected, because at this point you are really testing Kubernetes itself. So that would be an example. A counter example would be, for instance, everything related to networking, right? If you want to test network isolation between two namespaces, you know that there are multiple ways of achieving that, right? So one way is to use network policies if you really use a Kubernetes construct, but you could do that outside of Kubernetes itself, right? By relying on the infrastructure. So in that case, really checking the configuration wouldn't be sufficient because some implementation may decide to implement that outside of Kubernetes. So in that case, you really want to test the outcome, the behavior itself. So in that case, you would really start two pods in different namespaces and check if they can communicate with each other, right? I would say in general, whenever it's easy to do, we should really check for behavior for the outcome. But in some cases, when it's really straightforward, when a criteria can be only achieved through Kubernetes configuration, it's good enough to really test the configuration itself. So next, we define some categories of tests, or for each test, we could place them in one of these categories, and kind of overlap with the discussion the presentation we had before. So these categories, again, obviously can be discussed, but that would help really understand at a high level what we are trying to test with a given test, right? So the categories, I'm not going to go through all of them, but you have things like control plane protection, making sure that the cluster resources are protected. A basic one is obviously the tenant protection, making sure that namespaces are isolated across tenants. Network segmentation that we just discussed previously is another one that's pretty straightforward. Host protection is an interesting one also. You want to make sure that whatever tenant does, it doesn't impact the host itself where the workloads are running. Data protection is another one important. Obviously, you want to make sure that one tenant cannot, impact the data of another tenant. Fairness is another one that can be probably tough to test. We will see as we work on that. Making sure that resources are fairly are shared across tenants basically, and everybody can get what they need as it is defined for in their tenant. And then the self-service operations, it's kind of in a more advanced cases where we want to support self-service. So I can give you, maybe we can, Jim, what we can do is just look at one test and then we'll see a demo from shooting. You can scroll down to maybe the first test is just to see how that would look like in terms of specifying a test. So here we have a first test. Again, we use the kind of the format used by CIS, and we could decide, is it good or do we want some changes? So the first field is the profile that we are that this test is associated to. And then the type, is it configuration type of test or is it behavioral? And then the category. And then we describe the test. So in this case, just to understand what we are testing here, we want to make sure that a given tenant cannot list non-namespace resources, right? So all the resources outside of the namespace at the cluster level. So things like cluster role bindings, listing the nodes and things like that. And then we propose, so we explain why it's important to test that in the context of multi-tenancy. And then we also propose here, when it's possible, simple commands that could be used to actually verify that test. So in this case, you start by retrieving all the non-namespace resources. So for that, we're going to need the kubeconfig for the cluster admin role to be able to retrieve that. And once we have all these resources, then we can test that from the point of view of the tenant admin. So again, for this test, we will need a kubeconfig for the tenant admin. And for each of these non-namespace resources, we just try to list them. And the result should be that we should get a 4.3 error for all these operations. So that's how the test would be described. So next, let's see a demo and a discussion around the tools that we can use to implement this type of test. So Shooting is going to present that next.
Okay, hello everyone. This is Shooting from Nevada as well. So thanks, Damien and Jim. So now I'm gonna give you a quick demo about some of the sample tests we defined in this validation suite. And before that, just to give you some of the information, we have evaluated some of the existing tools that are from the community. One is the Kubebench and another is the Sonaboy. And for Kubebench, basically it is a tool to run the Kubernetes CIS benchmark test. So they allow the user to define the configurations and the end result of the each component, how they configured, and then they are validating through this configuration files. So as for an example I have here, this is checking the configurations of the API server that this flag is set to false. So basically they're performing the CIS benchmark test. And also for the Sonaboy, it is more like a diagnostic tools that can run the plugins. And each plugins can run the test or gather the data from your cluster. And two types of built-in plugins enabled by default in Sonaboy one is the Kubernetes end-to-end conformance test, and another is system logs gathering plugins. So the tools we're using for this multi-tenancy benchmarks is the E2E test framework, which is the Kubernetes end-to-end framework. So as you can see, the simple tests we defined for this benchmark are validating through the end result of kubectl. So it's kind of we're checking the outcomes of kubectl. So which E2E provides us a powerful tool to wrap the kubectl command, also all the functions to validate for your results. Okay, so to set up your test, we need some of the configurations from the user. The one is the kubeconfig for your cluster administrator, which is basically to get all the cluster-wide resource. And then we need the user to provide either the tenant kubeconfig or the namespace that they want to test with. Okay, so I have some of the small prototype of the sample test as Damien described. One is to to test that the tenant cannot list the cluster-wide resource, and another is more like the configuration checks, which is basically to validate the how the namespace resource code are configured. Okay, so as you can see, this is the configuration I have defined. I have the kubeconfig for administrator and also the kubeconfig for the tenant A, and also it's an associated namespace, which is default. Okay, and just to run the test, we're using the Go test tool, or either you can use Kubebench or any other tools can wrap over this. But also I enabled the log level up to 1 to give you more information of this. So let's run the test. Okay, the overall execution time may take up to 40 seconds. explain each of the specs we defined in this test suite. So first, this is the multi-tenancy benchmark. And you can see we're running 3 tests in total. And first, we're going to test the tenant permissions, which is to get the cluster-wide results. So we're using the administrator kubeconfig to get cluster-wide results first, and then we're validating through the tenant to get each of these cluster-wide results. This is the first one, and also we're also tested to edit the cluster-wide results. And the same test performed here is we're doing the annotate, but this is in the dry run mode, so we're not gonna change any of the existing results in your cluster. And also the third check is to check the configurations of how the tenant is configured. So in this case, we're validating the resource quota is configured for your tenant, which has to comply with how your cluster administrator resource quota is configured. And in the end, we can see that the test result and all the time it consumed. Okay, I think that's pretty much all I have. And also, I have the link to this simple test, and if you have any questions, you can ping me offline.
Yeah, so this is great. This is really good to have a concrete test suite, which I think the working group can build on. So this is what we were kind of discussing earlier, that there's a lot of, we need to have the right balance between a subjective description of a multi-tenancy architecture versus a specific formal benchmark that you can just run and score. And that way you'll get a quantitative report about a cluster saying, is it ready for multi-tenancy or not? So
right.
We'll have to keep building on it, but thank you for this wonderful start.
Thank you.
Yeah, so that's all we had to present. And of course, you know, based on feedback, I think a few ideas on what we could do next. One is we could start, and Sanjeev, you also were asking, is it better to do it in GitHub or Doc? So we can discuss that and, you know, kind of pick one way to start defining, let's say, some level 1 benchmarks, and then see how far we can get. And of course, you know, do this through, if we can collaborate through GitHub on the test implementations at least, then other folks can start contributing as well.
Yeah, I'll set up a call. Some of us who are working on similar things, we can connect offline. And this is exactly what I said to Sudeep also earlier. So what we'll do is, what I was thinking so far is we'll have some high-level documentation in GitHub. We'll continue to maintain Google Docs for a while it is still maturing, both for the architecture reference documentation as well as benchmark documentation. But for the actual test suite, I think we should go ahead and create a repo, and that can be directly in GitHub, just under the, whether it's under the incubator directory or whether some other one. Let's resolve that offline.
Okay.
Any other thoughts from the group? I think one of the things we're always going to find is that it's tricky to quantify security, because but this is a very good attempt to at least put some structure around it. So hopefully we can together, all of us can take it forward.
Yeah, this looks really useful.
Yeah, I would suggest for the test, I think it's great stuff. For level 1, I think it'd be ideal to list all the possible test cases. You have something keep in mind, because yeah, I think that's a good way. When I look at those tests, and I do think about how to incorporate all the user management in the tenant system, like REC. I think it is also a good guidance for Adrian to think about how can we pass those tests.
One other place to maybe integrate this is the certified Kubernetes supported distro kind of level. So not everybody has to run it on their cluster, that if they choose a certified distro, that it comes along with it.
Sorry, can you repeat, Kevin?
You know, there's a Kubernetes certified distro
right.
benchmark or what logo or whatever it is, right? And maybe there's an option here to have distros certified with this benchmark, so that individual users of that distro don't have to go certify it themselves.
Yeah, that's an interesting idea, right? So I think you're referring to, if you want to test any Kubernetes distribution, you go through the Sonobuoy tests, submit a PR, and then you get certified for that version. So similarly, in the future, this could be an automated process too.
Yeah.
Yeah, good idea.